Hello and welcome. My name is Christy Lansdowne, and I serve as the Executive Director of Achieving Cures Together. Just want to thank you so much for joining us today for our webinar, Microbiota Transplant Therapy for Autism. I'm just going to give a brief overview of our nonprofit organization for those of you who may not be familiar with us, and then I'll get to introducing our wonderful keynote speakers today. Achieving Cures Together is a nonprofit organization that was founded 10 years ago by an ulcerative colitis patient, Peter Westerhouse, who was severely sick and experienced remarkable healing through microbiota transplant therapy. Following his recovery, which included both microbiota transplants and a surgery to remove a high-risk section of intestine, Peter launched ACT and partnered with the University of Minnesota's Microbiota Therapeutics program, which is the nation's only academic program that is producing microbiota transplant therapies for clinical trials. Over the past decade, the field has grown tremendously. Our partners at the U of M have developed 3 different ways to administer microbiota therapy. The first is delivered by colonoscopy, which, as you can imagine, requires a lot of prep and is not very easy to administer frequently. Since then, they have also developed a capsule that patients can swallow, and most recently, a drinkable liquid, which expands access to more patients, specifically those who have difficulty swallowing capsules. Through our partnership with the University of Minnesota's Microbiota Therapeutics program, we've provided over 50,000 treatments to research clinical trials around the country and to patients with recurrent C. difficile infections. Today, ACT supports microbiota research targeting cardiovascular health, antibiotic resistance, cancer recovery, digestive system disorders, gut-brain connections, as we'll hear more about tonight in the webinar, and immune system disorders. Here is a list of some of the clinical trials that we're supporting right now with microbiota transplant therapies. And if you'd like to learn more about this groundbreaking research, please don't hesitate to reach out to us at info@achievingcures.com, and I'll put that in the chat. We'll also be hosting more webinars throughout the year. So if there's a topic you'd like us to explore, we'd really love to hear from you. And if you're in Minnesota or you're willing to travel, we invite you to join us at our fall event, Growing Hope, which will be hosted at September 12th. We promise there won't be snow. And so that's hosted at a local winery where you can meet some of our incredible research partners in person. Finally, none of this research would be possible without the generous support of our donors who share our vision of advancing microbiome therapy. If you're interested in contributing to this vital work, you can visit our website at achievingcures.com/donate. I now have the privilege of introducing our speakers and our research partners, Dr. James Adams and Dr. Rosa Krajmalnik-Brown. Dr. James Adams is a professor at Arizona State University and the director of the ASU Autism Asperger's Research Program, as well as a member of the Biodesign Center for Health through the Microbiomes. Dr. Adams' groundbreaking research focuses on the medical causes of autism, including nutritional deficiencies, heavy metal toxicity, and bacterial yeast overgrowths in the gut. Bacterial and yeast overgrowth in the gut. Dr. Adams has published over 150 peer-reviewed articles and leads multiple clinical trials for individuals with autism. It's also my pleasure to welcome Dr. Rosa Krajmalnik-Brown, who is also a professor at Arizona State University and the director of the Biodesign Center for Health through the Microbiomes. Her pioneering work explores the role of gut microbes in human health and health conditions, including autism, with a focus on microbiome-based therapies. Dr. Krajmalnik-Brown has authored over 150 peer-reviewed publications, has more than 10 patents issued, and leads innovative clinical trials aimed at translating microbiome science into real-world health solutions. So again, just want to thank you so much for joining us tonight, and we'll dive right into our webinar.
Thank you so much for the introduction. It is our pleasure to be here tonight with you to tell you more about bacterial and yeast metabolites. that are important in kids with autism. We'll share a little bit on new discovery testing, and you already heard microbiota transplant therapy treatment. Some disclaimers of or conflict of interest. Dr. James Adams and myself have patents related to diagnostic tests for autism. We co-founded a company called Autism Diagnostics. We also have patents related to microbiota transplant therapy for autism and other conditions. And we co-founded Gut-Brain Access Therapeutics. Dr. Adams also founded Autism Diagnostics Lab, and he also founded the nonprofit Autism Nutrition Research Center. And I'm going to start by telling you about our gut microbiome, the human gut microbiome. Microbes, which are bacteria, yeast, archaea, and viruses that live in our intestines, do a lot of amazing things for us. The first thing that they do for us is they help us digest the food that we eat. And they ferment that food, producing important chemicals, hydrogen, short-chain fatty acids, and metabolites. These metabolites travel through our body and actually interact with our immune system. They have some interaction with the brain, with the liver. And these microbes also produce vitamins and protect us from pathogenic or non-beneficial bacteria and feed our colonocytes. My research team has done a lot of work looking at how these microbes interact with us, with the host, in humans, not in mice. And one way that we do that is by doing interventions to the microbiome. And some of these interventions are, you're going to hear about today, microbiota transplant therapy. We've done interventions with diet, and we also have done interventions with probiotics, prebiotics, and probiotics. The gut microbiome is unique to each individual. It's a signature that we all have, and we have general stability through life. And I have general in quotations because today I'm going to show you how we can shift that microbiome somehow. It's affected by internal and external factors. I'm going to tell you a little bit about those factors today too. It's altered in disease, and it's strongly affected by residence time, which is an important issue for, especially for children that at some point have constipation or diarrhea, because that will change the residence time. The microbial genomes in our body are more than 100 times more than the genes that we have in our human genome. So if we compare the genes that we have from microbes in our body and the genes that we have from ourselves, at the gene level, we are 1% human and 99% microbe. This is really important because this provides an opportunity to intervene in a part of our body that it's more plastic, that can be changed. And so, as I mentioned before, my research team has done work with a few diseases or disorders that affect our health. One of them is obesity and metabolism and autism. But there's a list here that you can see on your left side of many other diseases that have been influenced or correlated to the gut microbiome. And the potential impact that we can have by affecting or managing the microbiome in a positive way is that we can get better metabolism, better gastrointestinal health, behavior, improved behavior, better mood, hopefully less obesity and type 2 diabetes. And our microbiomes also affect drug activity. So the factors that affect our gut microbiome are multiple. Our gender affects the gut microbiome. Medications that we take will interact with the microbes in our intestines. Health conditions, as I mentioned before. Host genetics also affect the microbiome, interact with the microbiome, the environment, the activity that we have, mode of delivery, and diet. And it's important to mention that some of the factors that I just mentioned, which one of them is genetics and environmental factors, are also have also been correlated or been part of the etiology of autism. And a big part that my team and Dr. Adams' teams have been looking at are the microbes and how the microbes interact with the host and how they can be an important part of this ASD symptomology. And so also I want to mention that as I said before, since these factors affect the microbiome puts together the environment and the host and the diet and a few other important things for the host. Autism's diagnosis has been increasing dramatically in the United States. You can see here the numbers that in the year 2000, the diagnosis for age school children was 1 in 150. And the latest diagnosis in 2024 by the CDC is 1 in 31 school-age children. You can see how rapidly this is increasing. This diagnosis is usually based on behavior. There's no biochemical test for diagnosis. You're going to hear a little bit more about our research on that today. And there's no cure or treatment available. And the estimated cost in the United States is about 268 billion per year. So I just mentioned that the microbiome affects your health. I mentioned to you some of the important things that our beneficial microbes do. They produce these important vitamins and short-chain fatty acids. And when they're in sync with us and they're happy and they're healthy, this gives us a healthy gut, which interacts really nicely with every other part of our body and also with the brain. And that leads to healthy brain development. But when this goes out of sync and we have an unhealthy gut and an unhealthy community of microbes, then there's a production of harmful metabolites, which there's a list of examples here, and you'll hear about some of these in the later part of the presentation. And these can lead to many different problems in the body, but important for this presentation, neuroinflammation during development. We also know that worse GI symptoms correlate with worse autism symptoms. 40% kids and adults with autism have chronic gut problems like constipation, diarrhea, bloating, and pain. And like I said, worse gut symptoms lead to worse autism symptoms. So what we try to do is not just treat the symptoms, but treat the root cause, which is the microbiome, the bacteria, and the yeast that I just showed you in the previous slides. Dr. Adams, my collaborator, and you're going to hear more from him shortly, published in 2011 a paper where he showed that the children that had worse GI symptoms also had a higher ATEX subscore, which is a higher score for the severity of autism. And that's what you're seeing in this graph. You can see that the higher severity is always higher severity of GI symptoms always leads to higher severity of these important subscores for ASD. We also, Dr. Adams and I got inspired on the relationship between the gut and the brain, among other reasons, because of the seminal paper in 2000 that showed that kids with autism were giving a treatment of vancomycin, and while they were in the treatment of vancomycin, which you can see in the middle of this graph, their behavior improved. You can see this with the lines going up. Their behavior improved dramatically while they were on the treatment of vancomycin. However, after they stopped taking the vancomycin and there was a follow-up later, many of those improvements were lost. So this to us was a signal that there's some component of the gut microbiome that is interacting somehow with these kids' behavior and their brain. So we started doing work on the microbiome and autism more than 15 years ago. And there's been many papers, many studies, different findings when we talk about the microbiome and autism. But there's a few key things. One of them is that there's an increase of harmful microbes. Some examples are Suterella and some Clostridium. And there's a lack of beneficial microbes, which is one of the things that Dr. Adams and I found in our very first study. Some of these microbes are Bifidobacterium and Prevotella. And another thing that we found is that there's lower diversity. Like healthy gut is it's a gut that is very diverse, that has many different types of microbes that can help each other have a good microbial community and society. And years later, there was, which was about a couple of years ago, a study from Dr. Jamie Morton. He's the lead author of this paper, where he put a lot of studies that have done autism microbiome research. And it's a metadata analysis. And some of the things that he found with this analysis was that there were ASD-associated microbes, about 551 ASD-associated microbes. Hold on one second, sorry. About 551 associated microbes, and there was about 160 microbes that were associated to a healthy community in kids that were on the typically developing group. And they also found that they were able to, with a different analysis, replicate some of the findings that Dr. Adams and I are going to talk about on our first microbiota transplant therapy for kids with autism on our open label, which some of the things that we saw were increases in Prevotella and increases in Bifidobacterium, which are beneficial microbes, as I mentioned before. But importantly, they also looked at metabolites that were reported on different studies of kids with autism. And some of the metabolites that they found that were found in many papers different in these kids at different levels, at different concentrations, are metabolites of three important aromatic amino acids: tryptophan, phenylalanine, and tyrosine, and also metabolites that are from glutamate and glutamate synthesis and metabolites. And this is important because one of the ways one of the ways by which we hypothesize that the gut interacts with the brain is through metabolites. There are many different hypotheses of how our gut and our gut microbes can communicate with the brain. But I'm going to focus and point to you today this, which is bacterial molecules, which are fatty acids, which I mentioned, gamma aminobutyric acid, which is a product of this glutamate that I mentioned before. And here it mentions 5-HT precursors, which is a tryptophan metabolite, but we're going to tell you a little bit more about other metabolites today. And with this, I'm going to stop sharing and pass the presentation to my collaborator, Dr. Adams.
Okay, so give me just a moment to pull my screen up. And we'll change to full mode. So thanks, Dr. Rosie, very much for a great intro. So our research recently has found that roughly 90% of children with autism have extremely high levels of harmful metabolites produced by gut bacteria or yeast. And one example that we know the most about is p-cresol sulfate. 17 studies of it in children with autism, and every study finds it's increased. And this metabolite is not increased in every child. This particular one is increased in about 25% of children with autism. It's been found to correlate with autism severity. Higher levels of p-cresol sulfate tend to have worse autism symptoms. We know it's toxic to the gut, the body, and the brain in many ways. And we've discovered many other metabolites that are also significantly elevated in autism, many of which are structurally very similar. And we've discovered that almost every child with autism has one or more of these metabolites at extremely elevated levels. So we published a paper on one of these, paracresol, and that's an example of metabolites that affect the dopamine system. Just to give you a brief overview of that, in the gut, p-cresol acts as an antibiotic to kill off competing bacteria. It also weakens the intestinal barrier, causing leaky gut. In the brain, it interferes with neurotransmitter function and with neuronal growth and synthesis. Very importantly, it damages the mitochondria, creative oxidative stress. And by doing that, because mitochondria produce energy for every cell and every organ in the body, it impairs the function of the whole body. The liver converts p-cresol to p-cresol sulfate to try to get rid of it. But unfortunately, that reduces the sulfate pool for detoxification of other substances. In the kidneys, it's been known for many years to be highly toxic to the kidneys. It's known as a nephrotoxin, again, causing serious damage there. And unfortunately, there are studies showing that adults with autism have a higher rate than normal of chronic kidney disease. And we think this is one of the reasons. In the immune system, it damages the immune system ability to fight infections and to detect infections. And most importantly, for autism, it induces autistic symptoms in animals. So in a study in which mice were given p-cresol, the mice who received it began avoiding one another and developing antisocial behavior and autistic symptoms, unlike the mice just given saline who like to be together. But when these mice who had received P-cresol and developed autistic symptoms, when they were given a microbiota transplant from a healthy mouse, they recovered. And so if that works in animals, it's no surprise that it also can help children with autism. So we did a study with 50 children with autism and 48 typical children, ages 2 to 11. We looked at over 40 microbial metabolites in the urine. We found 32 of them were significantly higher in autism versus typically developing children. Many of these had never previously been measured. So we discovered a lot of new harmful metabolites. Still confirming the identity of all of them, but basically they fall into two categories. They're either modifications of phenylalanine and tyrosine, which affect the dopamine system, or modifications of tryptophan, which affect serotonin, and then serotonin is converted to make melatonin, the hormone that regulates sleep. Some of these are known to be harmful, and the rest are highly suspect because they're structurally very similar. So these alterations in these neurotransmitters will affect your cognition, your attention, your mood, like anxiety, and also sleep, and thus we think affect many of the core symptoms and associated symptoms in autism. This is a plot of one of these other metabolites. It's a yeast metabolite, and the triangles are the children with autism. The blue squares are the typically developing children. We're plotting the level in each child of these metabolites. The scale on the left, the 1x is the average level in typical children, and you see most of the blue dots. The blue dots all fall within up to 10 times higher than average. But all these red triangles are the children with autism. They have levels 10 times, 100 times, even up to 1,000 times higher than that seen in typically developing children. So as a subset of these children who have unusually high levels of beta-carboline, which is a yeast metabolite and known to affect tryptophan, it's a metabolite of tryptophan and known to affect serotonin and melatonin. So we then developed a model we call the microbially derived metabolite model, in which we counted up how many metabolites were extremely elevated in any typical child. And so the children without autism, by definition, have 0 extremely elevated metabolites, whereas almost every child with autism has levels of several metabolites way above that of any typical child, on average about 7 metabolites that are extremely elevated. Only 3 of the children with autism did not have these extremely elevated metabolites. We discovered they had other genetic disorders. So this simple test, by counting up the number of these microbial metabolites that are extremely elevated, results in a very accurate test, 97% accurate, and distinguishing children from autism from typically developing children. And so you'll also notice that this is a plot of the number of metabolites versus age. And you'll see that in general, for children as young as age 2 up to age 11, there's not very much variation with age. So it suggests that it affects older children and possibly adults. We're doing research on that, and probably affects younger children as well. It's also important to note that GI symptoms we found in our research almost always begin in infancy and last for many years. And so we suspect that this, again, means it's likely associated with autism etiology, the development of autism symptoms. The 3 children who did not have these elevated metabolites had these 3 other genetic disorders. So we're being very bold here and proposing a new autism phenotype, a subset of children with autism who have unusually high levels of any of these certain microbial metabolites derived from tryptophan or phenylalanine. On average, is 7 of these metabolites in each child with autism. Some have 1, some have up to 20 that are elevated. It's very varied. Some children have 1 metabolite, other children have others. What they all have in common is their metabolites that affect dopamine or serotonin, and hence have big effects on brain function. It's very variable from one child to another, but this subset seems to represent about 90% of children with autism, not excluding those with major genetic disorders. And very importantly, the very first study that Rosie and I did at Microbiota Transplant for Autism showed that we could decrease levels of p-cresol sulfate, fecal p-cresol sulfate, down to normal levels, decreased at 90%. And at the same time, that was when we saw big improvements in gut symptoms and autism symptoms. So to conclude, we've known for many years about 40% of children with autism have obvious gut problems, but many more seem to have hidden gut problems where these gut bacteria or yeast are producing metabolites that are probably substantially contributing to autism symptoms. These bacterial and yeast metabolites, as I mentioned, some of them are well known to affect not only the gut, but the brain, kidneys, immune system, mitochondria, and detoxification. And by affecting serotonin and dopamine, they have big effects on cognition, attention, mood, and also on sleep. It also explains very high rates of chronic kidney disease and Parkinson's in adults with autism. Adults with Parkinson's, for example, have roughly 8 times the normal level of p-cresol sulfate in their brain compared to typical people. So these toxins can accumulate there. Some of these microbially derived metabolites are known to cause autistic symptoms in mice. They correlate with autism severity. So we hypothesize they could be contributing to autism symptoms in humans. We developed this test, which yields 90% accuracy in differentiating children with autism from typical kids with a simple urine collection. We're proposing a specific phenotype, which is defined by our urine test. To put it very bluntly, in lay terms, we believe children with autism are drunk on these microbial metabolites in the same way that yeast can produce alcohol and many other toxins. It's pretty obvious that alcohol can affect brain function, and in the same way, these other metabolites can affect brain function. The exciting thing is that we've shown that we can decrease the levels of at least one of these metabolites. We're now investigating many others, and decreasing it was accompanied by big improvements in gut symptoms and autism symptoms. So we suspect that the treatment decreases the level of these other microbial metabolites. That's the work that we're doing now. And also, by eliminating the harmful ones, it allows the beneficial ones to grow. And Dr. Rosie will tell you more about that. But I will pause for just a moment to transition to our work on testing for these hidden gut infections. The exciting thing is we've now partnered with a company that Analudos, who now is offering this commercial test worldwide. Testing for gut infections in autism is complex because you can't see easily what's going on inside the gut. There are thousands of possible bacteria and yeast in the gut. Many are beneficial, but some are harmful. It's unclear which species or particular strains are producing these harmful metabolites. So we believe the best option is to just test for the levels of these harmful metabolites in urine, because that means that these harmful metabolites have left the gut and entered the body if they're coming out in the urine. So we formed a company, Autism Diagnostics, Dr. Rosie and I, which is a spin-off company from ASU. Our university awarded us the first place award across the entire university for this exciting startup. And we've been collaborating with Analudos for 3 years to commercialize this test. And as of a few months ago, it's now available. It's a simple urine test. It's easy just to collect first morning urine sample at home, freeze it, and ship it. Families can order the test themselves directly. The company we work with is in the United Kingdom. You just can contact them on their website, and they can ship a test kit to you. The test includes measures of harmful yeast metabolites. It includes measures of a number of harmful bacterial metabolites, both those related to dopamine and those related to serotonin and melatonin. It also looks at the key amino acids that are the precursors to those. And also a special bonus, the group we work with has for many years been measuring gluten and casein peptides, which are normally not present. Normally your body digests those, but they find that some children with autism and adults with autism have levels of these, and these peptides are hypothesized to affect brain function, and thus suggested you might want to consider a gluten-free or casein-free diet if they show up there. So how to interpret our test? Well, very soon we're going to be adding to the test the diagnostic criteria, which will tell you, is this a sample from a child with autism with gut dysbiosis or from a typically developing child? Most children with autism test positive, but there are some who don't have gut dysbiosis. They have a type we haven't included yet in our commercial test, whereas we have such a high cutoff that none of the typically developing children we've measured have positive levels. It lets you know if there's a yeast dysbiosis or bacterial dysbiosis. That helps you know, should you consider antifungals or probiotics and prebiotics. You can also see if there's abnormal levels of the neurotransmitter precursors. It helps you know if you're having a problem with digesting gluten or casein. The test is done with state-of-the-art equipment, LC mass spectrometry. We've worked hard to develop an excellent pediatric reference range for very healthy, typically developing children. We're collaborating with two autism experts who for 20 years have been measuring metabolites in urine, Dr. Paul Whiteley and Dr. Kevin Carr. So bottom line is excellent equipment, excellent reference ranges and staff, and they're very dedicated to their work on helping children and adults with autism. It's likely that these metabolites are also relevant to other gut and gut-brain conditions, which involve these harmful metabolites. We know, for example, with P-cresol, elevated in Parkinson's, chronic kidney disease, and suspect in a number of mood disorders as well. So you can go to the website, analudos.com, and order the test. It's available to anyone in the world. They'll have a deal with FedEx, so they can send you a kit, and then you can send a urine sample back from your home to them. So moving on, why is it that children, roughly 90% of children with autism have elevated levels of these harmful metabolites from gut bacteria and yeast? Dr. Rosie gave some discussion of that. The bottom line is we've observed levels of increased antibiotic use, levels of herbicides or pesticides in food in the home, poor infant gut bacteria at the start, low fiber diet. Many Americans just don't eat enough vegetables, fruit, beans, and whole grains. Many children with autism eat only a narrow variety of foods. You need to eat a wide variety of foods if you want to grow a wide variety of gut bacteria. Generally, the more types of gut bacteria, the healthier your gut. And also, 3 studies have shown that some children with autism have reduced digestive enzymes for simple sugars, especially low in lactase, the sugar that's in milk. So all of these factors can contribute to the generation of harmful gut microbes that produce harmful metabolites that can harm the gut, body, and brain, and interfere with your dopamine and serotonin and melatonin neurotransmitters, and hence worsen cognition, attention, mood, and sleep, we believe. So what is the treatment we've developed? Microbiota transplant therapy. It's an investigational treatment, not yet approved by the FDA. That's why we're doing our research studies on it. And it's been developed to transplant gut bacteria from very healthy donors into children and adults with autism. We've completed 4 successful clinical trials for autism and Pitt Hopkins. We have 2 more clinical trials underway. We've observed up to 80% reduction in gut symptoms. We've seen cases of severe autism, on average reducing to mild to moderate autism in children and in adults even with autism who have had symptoms for many years. We followed up participants in our studies for up to 2 years, and most of them are still finding continued benefit, often even more benefit as time goes on in terms of autism symptoms. Because of the success of these trials, Dr. Rosie and I and our collaborators at the University of Minnesota formed Gut-Brain Axis Therapeutics to fund our final clinical trial so we can get FDA approval of this treatment and make it available to everyone in the US and around the world. This is a unique company because it's been funded now by over 100 autism families to help autism families. We do still have openings now for more investors to help us fund our final phase 3 clinical trials and the last step towards FDA approval. So our microbiota transplant therapy includes 3 steps. First 2 weeks of an antibiotic. Dr. Rosie mentioned the major temporary benefits of the antibiotic we use, vancomycin, to kill off harmful bacteria. And then we do a 1 day of a bowel cleanse to remove most of the remaining bacteria. And then 8 to 16 weeks of the microbiome capsules. So shown on the left are some of the real capsules produced by our close collaborators, our colleagues at the University of Minnesota, Alex Koretz and Michael Sadowski. And they also have a powder version now, which we're using now as well in our studies. Unlike typical probiotics that only contain 1 to 10 species, and those are limited species that are aerobic, this contains of order 400 species from very healthy, very carefully selected healthy individuals. And these are primarily anaerobic bacteria. Most of your gut bacteria, more than 90%, are anaerobic bacteria, so we're giving the ones that will stay there. And these, by doing this treatment, we find that we can have a long-lasting effect on the gut microbiome. Dr. Rosie will show you evidence of that, and also a long-lasting effect on autism-related symptoms. So this is just some data from our first study showing that MTT greatly improves GI symptoms. So this is the level at baseline. At 1 is the absolute lowest possible score. So roughly 80% reduction by the end of treatment. 8 weeks later, benefits are still continuing. And then we stopped and waited and followed up with everyone 2 years after treatment had stopped. And most of the GI benefits were still continuing. A few people on poor diets who had antibiotics lost the GI benefit, but again, most of them still having good improvement. But autism symptoms, most parents have said that there was a great improvement and even more improvement as time went on. That we started out with over 80% in the severe range. By the end of a 2-year follow-up, we were now less than 20% in the severe range, 40% with mild to moderate autism, and roughly 45% below the cutoff for even mild autism. They had some symptoms, but again, very substantial improvement. According to our expert autism evaluator, roughly 47% improvement. This is an open label study. There's some placebo effect, but still very important. Then in summary, then what we saw is 80% reduction in gut symptoms, autism symptoms being reduced from severe to moderate down to mild, and very safe treatment. We treated over 100 children and adults with autism and had 0 dropouts due to adverse effects. So now let me turn it back to Dr. Rosie to tell you about the microbiota research on these participants.
So as I mentioned before, microbial diversity is something necessary for a healthy gut. And an example that I like to use, or an analogy that I like to use for this high diversity is good, is if you think about a society, you want a society that has people with different jobs. You want doctors, you want engineers, you want teachers, you want many of them also, because you don't want things to collapse if one of them gets sick. So you want a lot of them, and you want all the jobs to be available. So that's the same with microbes. High diversity means a society of microbes that has all the jobs covered and a lot of the microbes doing each job. So we want that. So in this graph, you can see Faith PD, which is a measurement of diversity. The higher the number, the better the diversity. And the green line is the average diversity of our neurotypical kids, which were not treated, but they were just used as a comparison. And here you can see the median of the diversity of the kids with autism when the trial started. It's in the box on the line. When the trial started, those are our kids that were going to be treated. And the orange lines are the average diversities of our donors, the microbiota product. That's what we call our donors. And you can see that at 3 weeks, there was not a huge increase because these kids were just treated with a bump of antibiotic and then given the microbiota. But at 10 weeks, which is the end of the treatment, the diversity increased. And at 18 weeks, which is 8 weeks after treatment, we did a follow-up. We designed the study with a follow-up because we knew about this vancomycin study where we saw that the kids improved during treatment, but then regress after treatment. So we wanted to see, what if our treatment is great, but we want to see, do they remain, do the benefits remain after treatment? So we did this 8 weeks follow-up. We can see the diversity is even higher at follow-up. And a 2-year follow-up, which Dr. Adams didn't mention, but thanks to him, we did the 2-year follow-up because his study coordinators kept on getting calls from the parents of the kids that participated, letting them know that they were doing even better and better and better. So he said to me, Rosie, we need to do a follow-up study. We need to document this. We need to document that these kids are doing better. So we did. And so amazingly, they're doing even better. The diversity is even higher. He didn't mention also that in this treatment, no one dropped out of this treatment. Anyone who has run a clinical trial knows that anytime you run a clinical trial, you have dropouts. This was open label. Everyone knew that they were being treated, but the benefits were so amazing that no one dropped out. And not only no one dropped out, but they came back for the 2-year follow-up. So that was pretty amazing. We were very excited about that. So higher diversity, even higher at 2 years, and even higher than the typically developing kids. If you see the green line there, like our kids are even higher than the typical developing kids. So now I'm going to show you what happened with the next slide, Jim. Okay, we gave them microbiota from a donor. So what happened to the microbiota, to the gut microbiota of these kids? Did it become more similar to the donor? So what you're looking at in this graph is something that we call unweighted unifrac factor, which is a measurement of the similarity. The lower the number, the more similar it is to whatever you're comparing. So in this graph, we're comparing the recipient's microbiota to the microbiota of the donors. And you can see that in the beginning, it's about 0.5, which you can see that's where the green average neurotypical line is. So it's the average diversity between you and your neighbor or anyone randomly. And as we treated these children, you can see that the number goes down, which means they're more similar to the donor. However, we treated them, they became really similar to the donor, and slowly at 10 weeks and at 18 weeks, they started losing a little bit of that similarity to the donor. And at 2-year follow-up, even though we had seen amazing improvements and amazing increase in diversity, they're not more similar to the donor than they are to their neighbor or to the other person they're playing with, which means that we change the gut environment and we allow these kids to recruit beneficial microbes and to end up with their own beneficial microbiota, which was very different to the one in the beginning, but it was also different to their donor. It was just a beneficial microbiota that it's their personal microbiota. Next slide. We also look at metabolites. Dr. Adams mentioned in the beginning a lot about metabolites that we measure in urine. Well, in this study, we measure them in plasma. And we measure a whole bunch of metabolites. And what you're looking at in this graph is the overall metabolome, which is putting together a matrix of all the metabolites in one dot or in one square. And what I want you to pay attention to is the circles that are red are our kids in the beginning of the study, which are in the big circle in ellipse in red in the beginning of the study. That's how the metabolome look like for these kids. And the typically developing kids are on the right on square, the red squares. And what I want you to pay attention to is after we treated them, after week 3, and even more after week 10, which is at the end of treatment, the metabolome or all the metabolites in that plasma sample migrated to be more similar to the kids that are typically developing. And so these metabolites that were floating around in their body became more similar to the metabolites of kids that are typically developing. And I'm not showing you that in the next slide because I know we were a little bit short on time, but one of the metabolites that changed in this treatment was paracresol sulfate. We saw changes of paracresol sulfate in fecal samples that after treatment was more similar for the kids with autism, was higher in the beginning, and it came down to levels that were more similar to the typically developing kids. Next. So that's you, Jim.
Okay. So thanks very much, Dr. Rosie. So after that after our first study, we then received a grant from the federal government for $1 million to do a study for adults with autism. So this is a randomized, double-blind, placebo-controlled study. We enrolled 56 participants and 51 completed, very high completion rate. We found it was very safe. The treatment group actually had fewer and less severe adverse effects than the placebo group. We found it was very effective. A medium effect size after 10 weeks, growing to a large effect size at 18 weeks, and GI symptoms also improved by 10 weeks. We're now working on optimizing the dose to improve benefits, but bottom line is this study was sufficient for justifying a phase 3 study, which is what we hope to start in a year from now if we can raise the funding. This is a chart of autism severity. The adults started out in the severe range. The green group is a treatment group. At the end of the first 10 weeks of treatment, they improved some. At the end of the next 8 weeks of treatment, they improved more. When we stopped treatment, they just kept on improving. So 18 months post-treatment, they'd gone on average from well in the severe range down into the mild to moderate range. For adults who had had autism symptoms for 20, 30, 40, 50 years, we could help them. For the orange is the placebo group. Initially, not much change. And then we switched them to the real treatment, but without vancomycin. There was some benefit. And then we followed them for another 6, 12, and 18 months. And they improved some, but they still stayed in the severe range. And that was important because we needed to prove to the FDA. They asked us, did we really need to use vancomycin? And the answer is yes. It's pretty obvious those who received the vancomycin and the extra 8 weeks of treatment improved more than those who had the treatment without the vancomycin. In terms of the type of symptoms that we saw, the green is a treatment group, the orange is the placebo group. We looked at 20 different symptoms, and we saw that the treatment group improved more than the placebo group for all of these symptoms. On the left, 65% reduction in tantrums versus about 25% for the placebo group, but also more improvement in gut symptoms and in aggression, hyperactivity, mood, self-injury, sleep, and more. Many of these symptoms relate again to your neurotransmitters, your dopamine and serotonin. These are mood disorders, which improved by the treatment. So now let me turn it over to Dr. Rosie to tell you about changes in the gut bacteria in the adults.
So changes in the gut bacteria, I'm just going to give you one example that I think illustrates really nicely the change in a beneficial microbe, which is bifidobacteria. And you can see on the left side, the group that was treated initially, which we can see in red, the baseline average on bifidobacteria. It comes down to vancomycin, which makes sense. It's an antibiotic. It kills these microbes. And we can see that after we provided the MTT at the end of part 1, increases dramatically, and we can see that the increases remain after the end of part 2. This figure also shows very nicely how this doesn't happen during placebo treatment. So on the right, you can see our placebo group at baseline, which happened to be much higher in the beginning. I don't know why, that was random, but it doesn't change while we're not treating them. And once we provide the treatment, which is at the last part of the figure that you see, which is at the end of part 2, you can see an increase in bifidobacteria. So that's a really nice sample that shows that this is not anything placebo because these are measurements, and we can see that there's a definite, important, and significant increase of these beneficial microbes during the treatment, which doesn't happen on the placebo group. Next. So another thing that we saw, and this is, I know, a very busy slide, so follow me. So in this slide, every dot is the whole microbiome of a sample. And in the left side, you can see on the red ellipse is our participants before they were treated. That's the baseline. All the participants are on that red ellipse. And then we had 2 different sources of microbiota. At the top, you can see on green our humin donors, which are the microbiota from humin. And on the bottom, on pink, you can see the finch On black, you can see the Finch donors. You can also see that when these patients were treated with vancomycin, everything migrates to the left, which is the blue ellipse of vancomycin. So every microbiome migrates to that left. They look very similar, regardless of who is in this. They all look similar. But after we provide vancomycin in this graph, they migrate to the two different parts of the graph. They migrate to the top, which is your human recipients, which are the green dots, or they migrate to the bottom, which are the pink dots, if they receive the Finch product. So they take a different shape depending on what the microbial product is, which is really, really interesting. And on the right, you can see that nothing groups on the placebo or donors, which are the green dots and the black dots. Everything else is just spread out. There's no grouping. Next.
Okay, so just to give you a sense from some of the families, we'll share a couple quotes with you. One father said he believed MTT was foundational for his son. He seems happier and more well-adjusted, less anxious, less OCD, more receptive to typical social interactions. Troublesome behaviors and outbursts are now much less frequent and less intense. He's sleeping much better. Daily bowels are regular and normal. Another parent said, my son is 30, ADD and autistic. He's always had GI problems since he was a baby. This study was a miracle for him. No more pain, smell, or mess. Wonderful, more than we could have hoped for. And a bonus, his depression and anxiety levels are way down. Again, by changing the neurotransmitters, we're changing mood and behavior and improving a lot of those mental health issues. So how are we going to get this treatment out to millions of people? Well, we want to achieve FDA approval. So for Pitt-Hopkins, we've been working on a very rare condition called Pitt-Hopkins. It affects about 1,500 people in the US. It's associated with very severe autism and also very severe constipation, even worse than we see in autism. Our first study found very good benefit. Our second study is now underway and is going well, and will finish in about a year from now. And then at that point, we'll then go ahead and apply for FDA approval. The FDA has granted us orphan drug designation, meaning because it's such a rare condition, we only need 2 trials to be able to apply for FDA approval. Then it will be on the market for Pitt-Hopkins. But for autism, we've completed 3 trials. We're now doing a 4th study because we've discovered that it's such a safe treatment, we can go to a higher dose. Our hope is that a higher dose may result in even more benefit than we've seen so far. And so once we have the results of that study, then we'll be ready to start a phase 3 study, which is the final step towards FDA approval. But the big but is we need to raise of order $20 million to be able to start that final phase 3 study, just like phase 2 study, but bigger, many more people, many sites around the country. We have a bunch of sites ready to go. We just need the money for that. So that's why Dr. Rosie and I formed with our colleagues at the University of Minnesota this unique company, Gut Brain Axis Therapeutics, that's funded by autism families to help autism families. We've already raised $8 million from over 100 autism families. That's sufficient to fund our current studies. We now need to raise about $20 million for a final phase 3 study. There's a potential for very high profits for investors. There's a chance to make a difference in your child's life, and the lives of millions of others. And you can learn more at future webinars. We have those scheduled over the next couple of weeks if you want to learn more. And so just to summarize, we have over 90%, we've discovered about 90% of children with autism have extremely elevated levels of harmful microbial metabolites from gut bacteria or yeast. These metabolites are very different from one another in many cases. What they have in common is they affect key neurotransmitters, dopamine, serotonin, and related metabolites. These, some of these are known to be able to cause autistic symptoms in animals, and those animals can be recovered by microbiota transplant. We suspect that these metabolites can contribute to autism symptoms in humans as well. We've worked with a company at Aludos. We formed our own company, Autism Diagnostics. And Aludos is now offering their combined gut health test, and you can order it directly from their website to help you know if your child has a bacterial or yeast, high levels of harmful metabolites from bacteria or yeast. And we've been working very hard for over 10 years now on our microbiota transplant therapy. It's very promising because we're replacing harmful gut bacteria with beneficial bacteria from the top few percent healthiest donors. We found it improves gut symptoms and autism symptoms with benefits continuing at up to a couple of years formal follow-up. We just need one more big study to get FDA approval, and so we'd love your help with that. You can get more information on our company at this website. You can go here for more information on our research, or to Aludos if you want to learn more about their test. And again, we want to acknowledge and thank the many autism families and Pitt Hopkins families and their supporters. We want to thank the many different groups who have provided funding for our work. I want to especially thank the over 80 autism families who are investing now in our company. I want to thank our tremendous research team in Rosie's group and mine, working closely together, and very much thank our wonderful collaborators at the University of Minnesota, Dr. Koritz and Dr. Sadowski. And we want to thank our colleagues at Aludos, and especially thank ACT for hosting this webinar for us. So with that, I think are we turning it back to ACT to say a few words?
Thank you. We just really want to thank Dr. Krajmalnik-Brown and Dr. Adams for sharing the incredible advancements that they are leading in autism research. And also thank you to everyone who joined our webinar today. We will be opening up for Q&A. And so I see we do have a few questions in the Q&A tab. And so if Dr. Adams and Dr. Krajmalnik-Brown want to answer those, we can move to that section. If you do have any questions, please feel free to enter them into that Q&A tab on the Zoom platform here.
Okay. Dr. Rosie, would you like to take the first question, or should I?
I think you should.
Okay. So the question is from someone who has a 23-year-old daughter with autism and ADHD, and they're asking, what is our experience? Do they benefit? We have treated both males and females, men and women who are adults with autism from ages 18 up to 55. And on average, what we've seen is people going from severe autism down to moderate autism at the end of treatment, and then over the next 18 months, seeing slowly, gradually continued improvements. What most parents tell us is the child just seems better able to learn language and social interaction and behavior. We also, they tell us the most common comment is the child just happier by removing the pain associated with diarrhea, constipation. Imagine if you've had constipation for a week. Imagine that's gone on for months and years and decades. And finally, that's improved. So that alone would result in a lot of good improvement in gut symptoms, in pain. But now we understand it's also neurological effects. And it's not just eliminating the harmful bacteria, but as Dr. Rosie has made very clear to me, it's by replacing those with beneficial bacteria that have a lot of benefits, as she described. Next question. My son is 13 years old with autism, always constipated. The stool shows dysbiotic flora, Citrobacter complex. What is the best supplement or medication for constipation? Dr. Rosie, do you want to try taking that?
High fiber, but I don't know if you want to add to that. High fiber is one of the best things for constipation. I don't normally do medical recommendations, but high fiber is a really good recommendation for constipation. I don't know if you want to add to that, Jim.
Yeah, we have to be cautious because we're not physicians, but certainly look, a major factor we believe in the health of many people in the U.S. is just low fiber consumption. Women consume about half the normal fiber. Men are even worse. We consume only a third the normal fiber. And so that is a major contributor because the fiber is a very important food for certain gut bacteria that produce butyrate, the major nutrient for the cells that line the gut. So without enough fiber, the cells that line the gut are starving. But unfortunately, we've seen that giving high fiber alone doesn't necessarily seem to cure it because by that point the infection's there. And so, in my experience, again, I'm not a physician, but talking with many families, um, fiber can help prevent these problems, but not necessarily help treat it. And so that's why we have a whole nother talk on that. But there are many treatments you can do. But a very important point is trying to keep constipation through a variety of treatments to reduce the constipation because the longer the stool is in the gut, the longer it's fermenting. If you think about a bottle of wine, the longer it ferments, the more alcohol that's produced. So we think it's very important to keep things moving. One bowel movement a day, or even one for each meal, is really ideal, I think. So there are lots of laxatives, stool softeners, changing diet can be important, many things that can be done. Um, okay, next question. How is this test endoglutose different from the organic acid test by Mosaic? Well, part of the difference is that the test involves a number of metabolites, which we have several of which we've discovered have not been previously measured in autism. We've also have measured very carefully the levels in children, so we have an excellent pediatric reference range. We're working on the first paper, which is going to show that this test is a diagnostic test for autism. And that paper we hope to release within a month. And so that's going to be very powerful evidence of the strength of our test. The test is priced in British pounds. So the test is roughly 205 British pounds, which is about $260 roughly. So it's actually quite a bit cheaper than the Great Plains test. Dr. Rosa, do you want to take the next question? How do we participate in trials?
You can take it. I think I would say the same as you, that they go to autism.asu.edu and they get on our email list, and that way they will learn about them, unless you want to add more about that.
Yeah, I just say that the challenge we have is that there's so many families who want to be in our studies. With our last study, we had 60 openings. We had 500 applications the first 24 hours. We had 1,000 by the first week. So there's just a huge demand. We'd love to treat everyone, but we just don't have the funding to do it. And that's why we've decided finally to just form our own company. And luckily, thankfully, 100 plus families now are helping us move our research ahead. Is P-Cresol the same as For-Cresol?
Yes.
Thank you. How can we apply for phase 3 trials? We can't open applications for the studies until we have funding for them and until we have approval from the FDA. The FDA has approved all of the other studies we've asked for so far, but we need that $20 million to be able to start the next study. When we have that, then we will apply, but we will be sending out notices to our email list. And so if you're receiving emails from me currently, you're on my email list. Otherwise, you can go to our website down here, autism.asu.edu, and sign up, and then you'll be notified when we have openings in our next study. And our study is open to anyone in the U.S. So you're able to participate from anywhere in the U.S. Another study is that the normal level of P-Cresol is around 2,000. Data had a level of 19,000. Yeah, that's very high. And she reduced that marker down to 16,000 in 2 months of FMT. What could be the reason that the marker didn't go lower than the treatment? Well, I don't think you were in one of our studies, unless I'm wrong. And so the issue is that there are many different ways to do FMT. We found that it's very important who the donor is. We found it's very important to pre-treat with vancomycin. We believe the bowel cleanse is very important as well because you're removing most of the competition. And then we're very patient. We treat over 8 to 16 weeks. We found 16 weeks was better than 8 weeks. But also we found the donor is very, very important. The University of Minnesota, they screen donors very extensively. So the top few percent healthiest people in the US. And so those, it's very, very important who the donor is. For other conditions like Clostridium difficile, almost any healthy person can be a donor. For autism, it's a much more intractable infection. It doesn't disappear in a few days. It takes many weeks of treatment. So that would be my guess. How much is it? So microbiota transplant is not available yet, but we hope it will be in a couple years approved for Pitt-Hopkins and in about 5 years approved for autism. The price will probably be high. I don't want to shock you, but it will be about the price of 2 years of a new psychiatric medication, which is about $25,000. And we hope once it's approved by the FDA, then it will automatically be covered by Medicaid. Most children with autism have Medicaid coverage, so it'll be free or nearly free. But also we hope insurance companies will cover it too. So many kids with autism are on multiple psychiatric medications. The cost of it will be about the cost of 2 years of one medication. How does the urine sample stay frozen during shipping? With the current shipping, these metabolites are very stable. So although we asked that it be shipped frozen initially, it was stable for a couple weeks because of a special preservative that we add to the urine container. And so it's fine that it thaws during shipping. Someone says they've ordered a test for their 22-year-old son. What happens after that? After that, within typically 2 weeks, you will receive the test results back with an explanation of those test results. As a commercial lab, Analudos is only able to give limited explanations of the test. They are not allowed to give advice on treatment. But the nonprofit I've created, Autism Nutrition Research Center, we have a consultant there who can help with interpreting the test results and discussing different possible options to educate you, again, depending on what the result shows. So there are a number of treatments out there. If there's a fungal infection, antifungals like nystatin or diflucan, a low sugar diet. Bacterial infections, as I've said, are much trickier. And MTT seems the most promising, but there are other things you can do in the meantime. Next question, are you seeking participants for your final study, and how can you apply? I've already answered that. Yes, we hope to have openings for about 200 participants or more, but we can't advertise it yet until we have the funding to do the study. What is the effect on speech? We have seen speech is one of the most complex functions. So we see simple symptoms like mood and behavior change quickly. More complex skills like speech change more slowly. And so, but we have seen, for example, in one woman with Pitt-Hopkins, age 45 years old, had never spoken before, and has begun to say her first few meaningful words at age 45. And you can imagine how thrilled the parents are waiting 45 years to hear their daughter finally say her first few words. But again, that's one of the slowest, more complex skills, but also many children become better at expressing themselves through nonverbal means as well. Dr. Marty McKay, the FDA commissioner, has announced a program to expedite new drugs. They've announced that there will be a program, um, but the details on it are not yet clear. But we certainly hope that that will benefit approval. They've talked about changing typical FDA approvals from 12 months. Their goal is to get it down to 1 to 2 months, which would be tremendous. So they plan to do that for important conditions and hope they would view autism as an important condition. Dr. Rosie, do you want to take the next question? Have you considered this treatment for elderly with dementia?
You can take it. I'll take one later.
Okay. So people who, as they age, the diversity of their gut bacteria can decrease for a variety of reasons. And so, yes, where there's actually a venture capital firm interested in longevity. We know Christy with Achieving Cures Together mentioned that Dr. Koritz's team and Dr. Sadowski's team is helping with over 15 different clinical trials, including for heart disease and for cancer recovery. Those are the two top killers in the US. So if you can help reduce those symptoms, that alone should increase not just longevity, but health, increasing health span. So yes, we think could potentially be very helpful. Our focus is on autism, but again, people who are elderly can be very prone to gut issues as well. So
I'm gonna add to that two conditions that have been also very strongly correlated to changes in the microbiome are Alzheimer's and Parkinson's. So not just dementia. So we're not doing trials for that. But once we get this hopefully approved for autism, that would be another area of interest because changing the microbiome on those patients also might have huge impact.
yes, absolutely. Next question, is it possible to receive a copy of the slides? I believe, Dr. Rosie?
I don't know, maybe we can talk about that offline if that's okay.
Yes.
We will be sending out a recording of the webinar, and so you'd be able to view slides through the recording if you're interested.
Okay. Are you familiar with the work of Dr. Markova, showing the mothers of children with autism have L forms of microbes in the blood? Oh, yes, I think I remember seeing a study about that, but there was a question about the methods they were using, and I haven't seen a replication of it. So I'll just say
I have not seen the study, but I know that in the microbiome world, there was a lot of controversy about some studies that claimed that there was microbes in the placenta, and those turned out to be not true. The microbes that were being sequenced were contamination. So in the microbiome world, we believe that the placenta is sterile.
Yeah.
So I'm not sure how this would work.
Yeah. So I think it's not very likely, but again, so look for a replication study there. What are things that can be done until FMT is available? So prebiotics, which are typically two of the major categories of prebiotics are those that contain fiber. But unfortunately, some studies have shown that a single fiber source is not can be harmful rather than beneficial. So the best sources of fiber are what you normally have in your human diet. So a variety of fruits, whole fruits, whole vegetables, legumes or beans, and whole fiber, whole grains are probably the best sources of fiber, is my hypothesis. Also for younger children, human milk oligosaccharides, which are the fourth most common ingredient in mother's milk, are very important for certain beneficial bacteria. In fact, Dr. Rosie, I don't know if you want to talk more about that.
So Jim, I agree with you that in my mind and in my opinion, diet and a high fiber diet and the foods that you mentioned are the best high fiber foods are important, but it's very challenging to get a kid to eat what you want them to eat. And so I mean, I know that as a mom. So we have the best intentions and we want our kids to eat healthy and to eat fiber. But that's one of the things we don't have control over. So that's probably why they're asking us this. I don't know about a good fiber supplement, but I understand why the question comes our way because a pill is usually easier. A pill or a powder or something that you add to a shake, it's easier to do with a child than encourage them or try to coach them to eat healthy.
Yeah. So the way I think of it is that we're dealing with what I would call an infection in the gut. And so the cause, many contributing factors potentially, but the fiber can help support, but doesn't seem able to fight the infections necessarily, at least with the ones that have been used so far. There was a meta-analysis of many probiotic studies. There are over about 12 probiotic studies for autism have been done. Unfortunately, a meta-analysis shows they have zero benefit for gut symptoms in autism, and a very small benefit for autism symptoms. The ones that seem to be more beneficial are those that are multi-strain probiotics that had slightly more benefit. So if you were to use a standard probiotic, multi-strain one, but think of it this way: you have a person has of order 400 species in your gut, and so if let's talk in terms of a garden. If you want to grow corn, but you only have seeds for green beans, it doesn't work very well. Okay, it's just not biologically possible. But you can change the environment. So the probiotics can change the environment, as Dr. Rosie has educated me, changing the pH, changing other things. And so they may have some temporary benefit, but they don't stay. Whereas we've seen, Dr. Rosie, do you want to talk about engraftment?
Let me just, before I talk about engraftment, there's many studies on probiotics and there's a few actually that have shown some improvements. We recently published a review paper where we talk about interventions to change the microbiome in autism. And yes, MTT is the best, and I'm not going to say anything differently. MTT is the best, but it's not available. So some probiotics actually turned out to be beneficial. So you can look that up in our paper. Some probiotics, symbiotics are really good also because it's probiotics with prebiotics. It's like sending the microbes with their lunch, so that way they can actually do better. One of the things that Jim just mentioned, Dr. Adams just mentioned, is engraftment. I kind of show you how the microbiota becomes more similar to the microbiota becomes more similar to the microbiota of their donors. And that's when we know that the microbes that we added with the MTT stayed in the gut and didn't just went by. They stayed, they colonized, they did some stuff in there before they left the gut. And one of the things that people have seen with like the probiotics that you can purchase at the store is that they come in, they come out, which might be by design, right? Because you need to take them every day. In order for them to work, you need to take them every day because they come in, they come out. But as Dr. Adams mentioned, while they're there, they benefit the community. So while they're coming through the gut and they're doing their own thing and they're changing the pH and they're producing certain stuff, they help others. And that's what helps with the probiotics. So if you do probiotics, you need to take it every day. There's not a specific one I recommend. I do recommend that you see a review paper because we have a really nice summary there of studies that have been done and which ones had benefits and which ones not so much.
Yeah. But also, I think it's very important temporarily to deal with the symptoms of constipation. I was just talking to the family whose child had one bowel movement in 14 days. And so we're extremely constipated. So again, you just have a huge amount of fermentation there. And so just keeping things moving is very important. Getting enough liquids, very important. And temporarily using laxatives, suppositories. I'm not thrilled about enemas, but if absolutely necessary, that's part of it. But changing the diet, also important. Exercise is very important. Moving.
All the things that I mentioned that are important for the microbiome are important, right? The diet, the exercise, everything that it's important to be a healthy self, it's also important for our partners, which are, our microbes.
Yeah. Okay, next question. My son is 6, has had constipation, bad bacteria, and gut issues since he was 1 to 2. Once we do the amyloidose test, how can we get access to the treatment? Well, again, I think we've covered that. The MTT is not available yet, except through our studies, but there are things you can do in the meantime. If it's a yeast infection, you can do antifungals. If it's a bacterial infection, you can try treating some of the symptoms and trying to switch to a healthier diet or exercise, etc. Does microbiota transplant improve those with severe regressive autism, nonverbal to verbal? We have seen no difference between people with regressive versus early onset. Both groups seem to improve. Um, Again, we see improvements in language, in social interaction, in terms of behavior. So you generally first see improvements in gut symptoms, and then later improvements in mood, because that's relatively quick to change. Whereas learning the language, think about how many years it takes a young child to learn language. Our studies only go out to follow up at most 2 years. So how much change do we see in language from an infant to a 2-year-old? It takes time. Um, but yes, we do see improvements in language as well. But I don't want to say it's a cure. I'll say it's a substantially beneficial treatment, especially for gut, but also for core autism symptoms, for social interaction. How would one apply to participate in the phase 3 study? Again, just go to autism.asu.edu to sign up for our contact list. And then when we announce the study, we will announce it through our contact list. When will our phase 3 study start? It could start as soon as 6 months if we can get $20 million. We're working very hard to try to raise that. We've been very busy writing proposals and talking with a lot of people. But honestly, I think it's in the same way the autism community has already raised $8 million for us. We think it's a tremendous investment, but it's up to people to come to an investment talk if they want to learn more about it. We already covered for P-Cresol. For Cresol is just another name for P-Cresol. Okay, we've talked about tests that can be done in the interim. If you want more, we do have a mini talk on our gut-brain axis therapeutics website. We talk a bit more about the treatment options. Then also you can talk with our consultant to review tests on a personal basis and get personal advice. We also have an expert nutritionist we can refer people to. Again, think of your gut microbiome changing every day, that roughly a third of your stool is gut bacteria. So you're flushing out a half pound of gut bacteria every day and growing a new half pound of gut bacteria, and they grow on the food you eat. So the food you provide is very important. Can the test be ordered by a nutritionist? Well, it could be, but any family can go to the website and order it. That this test, because it's from the UK, they don't require a physician to order the test. Any family can order it, but a physician can order it as well for you if you want, or a nutritionist. Will this video be available by replay? Yes, ACT will get it out after probably some light editing. What's our opinion on stem cell therapy? It's not approved yet by the FDA. They've made it available on a compassionate care or expanded access basis. I've been unimpressed with the studies I've seen of it so far, but I won't claim to be an expert on it. Can the test be ordered in Canada? Yes. Anyone in the world can order the test from them, from Anna PIs give the web address again for getting updates. Here's the websites to contact us or the companies. If P-Cresol is normal in my son, age 33 years old, would you still suggest FMT? P-Cresol is elevated in about a quarter of people with autism, but there are 30 some other metabolites we look at as well. So there are hundreds of different bacteria in the gut. And some children in autism, it's very variable. That's why it's been so confusing. But what they have in common is very similar structure. They all come from one of two key amino acids, and they just are corrupted versions of metabolites that lead to dopamine and serotonin. So P-cresol is not enough. There are many other metabolites to look at as well. How often do subjects take the MTT over the 16 weeks? It depends. At the start of the study, we sometimes have done it up to 3 times a day, and then we switch to a maintenance dose. We've done it every several days. We think every day is probably better. And so that's why we're going to more intensive therapy now to see if we can see even more benefit than we've seen in the past. Dr. Rosie, do you want to take the next question?
The vegetarian, yeah, is vegetarians and non-vegetarians Biota different? Yes, definitely. And you can change that. There's a study a few years ago that showed that a person that eats only meat or it's a heavily meat eater goes into a vegetarian diet, in 24 hours, they can see a change in the microbiota just by going into that vegetarian diet. And I would say vice versa, but usually it's very difficult to convince vegetarians to go into a meat diet. But yes, a vegetarian diet would lead to a very different microbiome than a diet that has meat.
Again, just diet is so important. Leucovorin has helped so many children with autism. Is there any correlation with leucovorin and these harmful metabolites? Yes, it's a long story. But to say it briefly, one of the key factors is that P-cresol, for example, damages the mitochondria, which are the energy-producing factories in every cell. Historically, mitochondria were probably bacteria that became part of our body. So it's no surprise that P-cresol, which is an antibiotic, damages the mitochondria. By damaging the mitochondria, you have 2 problems. You have less ATP produced, that's the energy for the brain and the body, and you create more oxidative stress. The oxidative stress, in turn, interferes with folate metabolism. So leucovorin is just high-dose folate, a B vitamin. And so we think that's part of the reason. There's a lot more to this I don't have time to go into, but we believe that's a substantial part of what's going on. Folate metabolism is very important. The question is, why do children with autism need that? And I think this is probably one contributing factor. I don't know, Dr. Rosie, if you want to say anything more on that.
No, you're good.
Okay. Seizure and epilepsy benefit from MTT. This is such a great question. In our review paper on P-cresol, where there's one small study we mentioned that shows that people with seizures, not people with autism, but people with seizures, have even higher levels of P-cresol than children with autism. We know that P-cresol, when administered to mice, can cause seizures in animals. Again, you're altering neurotransmitters. We saw in one of our MTT studies a child with Tourette syndrome, a seizure-like disorder, and after about 8 weeks, they were cured of Tourette's. They don't use the word cured lightly, but they were cured of their Tourette's after about 8 weeks. So I think it's very possible. I've written several papers on seizures with an expert, Dr. Fry. In roughly 80% of cases, we don't know the cause of seizures. And so we think it's very possible that these harmful metabolites could be contributing to seizures. About 20% of kids with autism have eventually developed seizures, but about 60 to 80% have abnormal epileptiforms or abnormal electrical activity. And again, we suspect that's due to these abnormal metabolites. But that up till now, we have not been studying children with autism who have seizures, because we first want to see if it's safe for children with autism who don't have seizures. But in our present studies, we are now including some people with seizures, and we'll see what the outcomes of those are. Dr. Rosie, feel free to add any more if you want.
Thank you. No.
And for funding, have you reviewed a public VC like Start Engine? I don't know that one in particular. We are certainly open to talking with VCs. We've spoken with a few, but there are some issues with our company. That our company is more a long-term investment. It'll probably be about 5 years before, because we're focused on research, clinical trials for autism for 5 years. It'll be about 5 years before we'll be profitable. But then after that point, then like many other pharma companies, we hope for a lot of benefit. There's not too much I'm allowed to say now in this type of talk, but if you come to our investor seminar, I could say a lot more about this. Has Robert Kennedy been contacted? Please feel free to share results with him. We don't have direct contact with Mr. Kennedy, but I'm pleased that he's very interested in autism at least. And we are about to apply tomorrow for a study. Mr. Kennedy has encouraged, I believe it was him who encouraged a lot of extra investment in autism at the NIH. The NIH, although it's cutting funding in many areas, has increased funding for autism. And so one can apply for grants for up to $5 million. And so we have submitted a grant request for $5 million, and we're keeping our fingers crossed. It goes in tomorrow. Since MTT treatment is not yet FDA approved, is similar treatment available anywhere else in the world? There are places doing it. There have been some controversies in some cases. We don't recommend going to other countries doing it. Again, it's not FDA approved in the US. Dr. Rose, do you want to take the next question? Is P-cresol ever found in breast milk?
So I have never read publications on that, and I was actually looking it up right now. And the answer by ATSDR, which publishes all the toxicity reports, says that cresol has not been reported in breast milk. I think it's a great question. And the fact that it hasn't been reported doesn't mean that it's not there. Sometimes we don't know that it's there because I don't know if people have looked for it. But I'm not aware of publications with paracresol in breast milk. Do you want to add to that, Jim?
It gets into the blood, it gets into the brain, it gets into every cell in the body because it's damaging the mitochondria. So I'd suspect it's in breast milk too. That's our guess.
That doesn't mean that there's evidence, right? So there's no evidence so far, but that's a great question.
Yeah, but I think one of the most relevant studies is the one that Dr. Rosie actually published. Do you want to talk about the study of our stool samples being used in mice?
Yes, but that has nothing to do with breast milk. I agree with you, but that has nothing to do with breast milk. We actually provided some samples of microbiota. Well, it's fecal samples which have the microbiota of kids with autism and fecal samples of typically developing children, which were used to inoculate mice. And they were used to inoculate pregnant mice. And these pregnant mice had some offspring, and the offspring of the moms that were inoculated with the feces of the kids with autism had autistic-like behaviors. And the offspring of the mice that were inoculated with the feces of typically developing kids were normal. And so this is a good evidence that this is probably transmitted also through the mom. No evidence on breast milk, but that some of these microbes and metabolites can be transmitted through the mom. And it's important. The mom provides stuff to the children too.
Yeah. So
that's the study you wanted me to talk about, right?
Yeah. The bottom line is we know that infections during pregnancy, like rubella, greatly increase the risk of having a child with autism. To suspect that other infections, like a gut infection, could also contribute. But again, we don't know about breast milk.
But Jim, thinking as an engineer that thinks about where things go, breast milk probably has more compounds that are less soluble in water and maybe more soluble in like fat. And paracrystal sulfate, for example, it gets sulfated, so it gets secreted. That's why you find it in urine, because that's how we get rid of toxins in our body. We put either a little bit of sugar or we put a little bit of sulfate, and that makes them more soluble. And by being more soluble, we can get them out. And so because we have this amazing mechanism to make it more soluble so it'll come out, I don't know that it'll stay enough to be retained in breast milk. And so that might be one of the reasons why they haven't found it in breast milk.
Yeah. Dr. Rose, do you want to take the next question? Does MTT get down to the biofilm in the gut?
So the first thing that I'm going to tell you as a scientist, we have no evidence of one or the other because we haven't looked at biofilms. But I presume that it gets to some part of it because otherwise you wouldn't see what we see, which is the engraftment. You have the bacteria that travel throughout, that come in and come out, but you also have bacteria that stick and make part of a biofilm. So I would assume that it makes it to some part of the biofilm, probably not as deep as we would like to. These are all hypotheses and assumptions. We have no evidence because we would have to sample to actually say yes or no. And that's complicated.
Yeah. But there is evidence of engraftment that these bacteria stay for a long time after treatment.
Yeah, they stay. So that's why I think because they stay, I think they become part of the biofilm, at least provisionary. But I don't know that they make it to the very deep biofilm, which is what I think we create as we grow. That's why the microbiome is so important as an infant, because you're creating that biofilm that will be with you forever, for the rest of your life.
So next question, what are our thoughts on private practitioners in the US offering FMT following our protocol? FMT is not approved by the FDA. It's an investigational treatment. And the FDA would view that as illegal to do, as my understanding. So I think that's all we can say there. My child now has normal bowel movements. Would they still benefit? We know now that roughly, although 40% of kids and adults with autism have abnormal gut bacteria, have gut symptoms, roughly 90% have abnormal gut bacteria. The study that one of our research scientists led, looking at yeast, we found that children with autism with higher levels of yeast have more severe autism symptoms, but not worse gut symptoms. So there's some parts of the microbiome that seem to affect brain function, but not gut function. So that's why it's so important. There are 6 different studies showing elevated yeast in children with autism. And so we think you won't know about the effects of it other than doing a test for it. So I think that's why it's so important to do the test. Again, of order, a third, maybe up to a half of people with autism have what I would call a hidden gut infection. It's producing these harmful yeast metabolites, and it's treatable. We had one autism family just a week ago sent me an email saying they had their son tested. He had high levels of yeast according to our test. They treated him with nystatin and dramatic improvement within 30 days. But then they stopped treatment after 30 days and he lost the benefit. So unfortunately with antifungals, yeast, I've heard from many physicians say it comes back unless you use long-term antifungals and a low sugar, low carb diet to try to fight it off. So these yeast infections seem very persistent. Dr. Rose, I don't know if you want to talk more about that. Okay. Do some trial participants remain on other meds as well? Absolutely. We require that everyone not make any changes in their medications, supplements, or therapies during the treatment, except they are allowed to decrease treatment. So we've had a number of participants reduce or stop their use of GI medications. And so that's wonderful to see. We've seen some people stop their anti-anxiety medications because they no longer have anxiety. So those are the sort of treatment changes that we're pleased to see. All right. Thank you. Thank you. Sounds like we're getting near the end. Christy, should we close and just allow people to follow up with us individually for any questions if they have them?
Yes, that sounds great. I just want to give a huge thank you to Dr. Adams and Dr. Krajmalnik-Brown for taking their time today to share with us and for the years of research that you've put into helping autism patients and advancing research in this field. We're so excited to see the developments and these new trials coming forward. And so we're so grateful for the dedication that you've put into this work and to supporting patients and advancing research in medical care. So thank you so much. And we do want to say thank you to everyone for joining us today. We will be sending out, as Dr. Adams mentioned, a recording of the webinar. So you're welcome to rewatch it as well as share it with anyone else you think might be interested in the material. Please feel free to reach out to us at info@achievingcures.com. If you do have any questions about that, again, as Dr. Adams and Dr. Krajmalnik-Brown mentioned, their websites are also available in the presentation if you have questions and want to look at some of the materials that they've provided. So thank you again to everybody for joining us, and we hope you have a great rest of your night.
Thank you all.
Thank you.